Good morning, afternoon, or evening. How y'all doing today? Welcome back to Mr. Morrow's geometry class, honors geometry class. Today we're going to wrap up chapter 6. We're going to talk about basic facts of parallel planes. And let's just get right to it. If a plane and a line are parallel, that means they do not intersect. Okay? So if I tell you that line A and plane B do not intersect, you can automatically have as a given fact that the line and the plane are parallel. So again, if line A and plane B do not intersect, then line A is parallel to plane B. The same thing goes for two planes that do not intersect. Two planes that do not intersect are parallel. So here in the figure that we have here to the left, if plane A and plane B do not intersect, then plane A is parallel to plane B. It's that simple. Remember, if they don't intersect, then they're going to be parallel. Now, here's where things get a little bit complicated. Skew lines, okay? Skew lines, if you remember, are lines that are on different planes and never intersect. So here's where the confusion comes. When people hear they don't intersect, they say, oh, okay, they're parallel. No. Skew lines are not parallel, and skew lines are not coplanar. So what am I talking about? Let's look at these two figures that I have here, okay? Let's look at this guy here first. You have plane N with line A on it, and plane M with lines C and B on it, okay? In this case, the whole lines are dashed. That doesn't mean that it's going through. It just means that I wanted to differentiate between the two planes. So just because line A and line B do not intersect, since they are skew, that means they are on different planes. That means they are not parallel. These two lines are not parallel. Okay? Just because you have parallel planes, it does not mean that all of the lines on those individual planes are parallel. These are called skew lines. So skew lines are lines on different planes that never intersect. However, skew lines are not parallel and they're non-coplanar. They're not coplanar. Okay? If you look at the next figure here, this guy in green, you have plane N and plane M. Line D and line E are not parallel. They do not intersect, but they're not parallel because they are skew lines. So this is very, very important. I think that's the hardest part of this section, to understand the difference between parallel lines and skew lines. Skew lines, again, are not coplanar, and since they're not coplanar, they're never going to intersect. But that does not make them parallel. Okay? If a line and a plane do not intersect, they will be parallel. If two planes do not intersect, they will be parallel. But if you have skew lines, those are not parallel despite the fact that they do not intersect. Skew lines are on different planes, and that's why they're not going to intersect, but they're not parallel. Think about it like this. The ceiling and the floor, okay? If I draw a line on the floor this way, okay, it's going right across the floor here. And then I go to the back of the room and I draw a line going this way, almost perpendicular to it. Are they going to intersect? No, because they're on separate planes. So lines that are on separate planes are not going to be parallel. Now, are these two planes parallel? Yes. But are the individual lines drawn on these planes necessarily parallel? No. Does that help? Okay. Thank you, boys. Okay. Now, there is a planes intersection theorem. Again, I came up with the name. They just put like Theorem 49 or whatever it was. But the planes intersection theorem states the following. If a plane intersects two parallel planes, the lines of intersection are parallel. So if you see plane X and Y, they're in a light shade of purple. Those two planes do not intersect, and those two planes are parallel. But then you have here this blue plane that intersects both plane X and Y. The lines of intersection are parallel. So if a plane intersects two parallel planes, the lines of intersection are parallel. Kind of like if I put a column here, okay? A column right here in the middle that goes through the ceiling and the floor. The intersection line of where it hits the ceiling and where it hits the floor, those two lines, those are parallel lines because of the planes intersection theorem. Yes, sir, my brother.
Some cases like this would be using like alternate interior and same side interior, not.
Would you be able to use alternate interior and same side interior? If I had a diagonal that came through here, yes. Good question. Yes, sir. Absolutely, my brother. Absolutely. Well done. So if a plane intersects two parallel planes, then the lines of intersection are parallel. Because remember from yesterday, hopefully, when a line goes through a plane, that creates a foot. And when a plane intersects another plane, the intersection is a line. When you have a plane intersecting two parallel planes, the intersection lines are parallel. Does that make sense? Okay. What can be said of lines CD and AB if plane MBA and plane PDQ are parallel? What can be said of CD and AB? They're not congruent. They're parallel. AB will be parallel then to CD. Now, I'm curious, why would you say they're congruent? We just finished stating the planes intersection theorem, though. Okay? This shaded plane is intersecting these two non-shaded planes, which I'm telling you are parallel. So that means that the intersection lines have to be parallel. You feel me? Yes, no, maybe kind of, sort of? Okay. Now, these next properties, guys, you have to memorize. It's just the way it goes. Number one, if two planes are perpendicular to the same line, they are parallel to each other. Hopefully that makes sense, especially with the example that I gave you with the column. Okay? Or with this wall right here. This wall creates a 90-degree angle with the ceiling, and it creates a 90-degree angle with the floor. So that means that the ceiling and the floor are parallel. Does that make sense? I tried to create figures that really represented it clearly. Okay? Since this line is perpendicular to this plane, and it's perpendicular to this plane, that means that plane G and L are parallel. Does that make sense, boys? Yes, sir, my brother. It would be kind of corresponding angles. Kind of, but not really. Because not necessarily is that line A going up forever and B going up forever. Not necessarily are those parallel. Those are skew. Okay? but it's kind of the corresponding kind of thought behind it. Yes. So if a plane, if two planes rather, are perpendicular to the same line, then that means that those two planes are parallel. Number two, using the above figure, that's why I'm keeping the above figure here, we can state that if a line is perpendicular to one of two parallel planes, it is perpendicular to the other plane. So in that case, what this is saying is, if this line, DC, okay, is perpendicular to this plane L, and we know that plane L and plane L1 rather, not G, that plane L and L1 are parallel, then that means the intersection point of L1 will also create a perpendicular angle. So if a line is perpendicular to one of two parallel planes, it is perpendicular to the other plane as well. Yes?
It's kind of like a converse.
It's kind of like a converse. These aren't really theorems, but yes, it could be seen as kind of a converse. Very good question, sir. Good statement, rather. Well done. Okay? Okay, number three. If two planes are parallel to the same plane, they are parallel to each other. This is kind of like transitive, kind of. If A is parallel to B and C is parallel to B, then that means A is parallel to C. If two planes are parallel to the same plane, then they are parallel to each other. If plane A is parallel to plane B and plane C is parallel to plane A as well, then plane C is parallel to plane B as well, then plane A is parallel to plane C. There's no real symbol for marking parallel planes. It'd have to be given to you. It'd have to be a statement. Thank you, sir. Number four, if two lines are perpendicular to the same plane, they are parallel to each other. Now here, it's not skew. This line AB is perpendicular to plane Q here. And CD is also perpendicular to plane Q. So that means that AB and AC are parallel to each other. So if two lines are perpendicular to the same plane, they are parallel to each other. Okay. I'm sorry, but we got a boogie. Sorry, we have a video. Number five, it's kind of the converse. Using the above figure, if a plane is perpendicular to one of two lines, it is perpendicular to the other line as well. If a plane is perpendicular to one of two, and actually that's messed up, one of two parallel lines. Thank you, sir. My bad. No excuse. It is perpendicular to the other line as well. So what that's saying is if line AB and line CD are parallel and plane Q is perpendicular to line AB, then plane Q will be perpendicular to line CD as well. Okay? Now, the bell's going to ring. I have one example, which is a proof. I know you guys got to go to class. I have lunch, so I'm going to stay, finish up my proof. When you guys leave, just leave kind of quietly, and God bless you. Do your homework. Prepare for your quiz tomorrow. Hope you learned a lot. Have a wonderful day. God bless. I am going to start the proof, though, so please don't make a lot of noise when you leave. Please. And thank you. Okay. So in this particular case, given is that plane M is parallel to N. Like I had stated before, they're always going to tell you that they're parallel. AB lies in plane M. CD lies in plane N. And AC is parallel to BD. They want to prove that AD bisects BC. So, let's go ahead and start our proof up. Okay, number one, we know that M is parallel to N. That's a given. So if M is parallel to N, that's all we know, is that they're parallel. And we know that AB lies in plane M, which is given. And we know that CD lies in plane N, which is given. And we know that AC is parallel to BD. That is also given. So we know that AC is parallel to BD. From here we can determine that AC and BD determine a plane. So this right here is a plane itself. Why? Well, two parallel lines determine a plane. We learned that yesterday. Okay? From here, we can say that AB now is parallel to CD. Why? Well, if a plane intersects two parallel planes, which M and N are parallel, the lines of intersection are parallel. So since AB and CD are the intersection lines, okay, of two parallel planes, AB is parallel to CD. From here we can automatically remember, hopefully, that ABCD is now a parallelogram. Why? Because if both pairs of opposite sides of a quadrilateral are parallel, it is a parallelogram. And if it is a parallelogram, then we know that AD, which is a diagonal of the parallelogram, bisects BC. They actually bisect each other. Why? So it's one of the definitions of a parallelogram. The diagonals of a parallelogram bisect each other. And there you have it. Hope that helps. Have a wonderful day. Hope you learned a lot. God bless you and take care. Thank you.